Hi, I'm Abby, and in this video, I'm going to walk you through the ultrasound signal flow. In this presentation, I'm going to describe the key components of transmitting, receiving, and processing of an ultrasound signal. The transducer is the core of the ultrasound system. It acts as both the transmitter and the receiver of all the sound waves through what's called the piezoelectric effect. When electricity is applied to the piezoelectric crystal, or what's called the active element, it sends high frequency sound waves into the body. Those sound waves reflect off different tissues, and then the same crystals detect the echoes and convert those back into electric signals, which allows the transducer to both create and collect ultrasound data that ultimately forms the image. There are many components of the transducer that allow it to function properly. First, we have the wire that carries the electric signals from the ultrasound system to the transducer. Then we have the casing that protects all the internal components of the transducer. Then we have the backing material, which reduces ringing and helps improve axial resolution. Then we have the PZT itself, or the active element. Then we have the matching layer that helps the transfer of sound into the body. Then we have the electric shield, which helps prevent electric noise in the transducer, and the acoustic insulator, which prevents further vibrating in the case. If you imagine the ultrasound system to be like a symphony, then you can imagine the master synchronizer to be like the conductor. It makes sure everything works in sync and in perfect harmony, like the display, the pulsar, and the receiver, to make sure that all the sound waves are sent out in perfect sequence. Next, we have the pulsar. The pulsar functions during transmission, and it creates electrical signals that are sent to the transducer's PZT crystal that allows it to create the sound beams. After the ultrasound signal leaves the pulsar, it then goes to the beamformer. The beamformer is a sophisticated electronic device that takes the single electric spike from the pulsar and distributes it to all the active elements in an array transducer. Then the beamformer can control the timing delays so that it can steer and focus the sound beam. The beamformer has a special component called the transmit-receive switch. The transmit-receive switch is important in both transmission and reception. During transmission, the voltages are very high, and during reception, the voltages are very low. The transmit-receive switch helps protect the delicate components of the receiver and helps direct the electrical signals to where they should go. The sound pulse then goes to the receiver. The receiver collects all this information from the electrical signals and prepares it to ultimately be displayed on your screen as an image. In order for this to take place, there are 5 processes that must occur. They are amplification, compensation, compression, demodulation, and rejection. The first function of the receiver is amplification, or also known as receiver gain. This makes each of the returning signals larger and results in the image by making it brighter or darker depending on how it's adjusted by the sonographer. The second function of the receiver is compensation. As sound waves travel through the body, they attenuate with depth. Without compensation, the ultrasound image would be progressively darker as depth increases. Compensation creates an image that is uniformly bright from top to bottom. This can be adjusted by the sonographer with the slide bars on the console. The third function of the receiver is compression. Compression changes the grayscale characteristics of an image by keeping the grayscale content within the range of detection by the human eye, which is about 20 shades of gray. This is also called dynamic range or log compression. The fourth function is demodulation. This is a 2-part process. First, rectification converts all negative voltages into positive ones, and then enveloping or smoothing creates a smooth line around all the bumps to even them out. This actually has no effect on the image. The fifth and final function of the receiver is reject. This allows the sonographer to determine whether low-level signals are meaningful diagnostic information or just meaningless noise. This is also called threshold or suppression. Next, the pulse goes to the analog to digital converter. This transforms the returning echo from the receiver, which is analog data, into digital data that the computer can read and understand. This step is essential because all of the image processing and display functions in our ultrasound system happen digitally. This allows the system to build and display the image that we see on our ultrasound screen. Finally, it makes it to the display where all of the processed data is visible in an image on the screen. This allows the sonographer to interpret the anatomy and the motion in real time. Finally, your image can be stored and saved in a PACS system, which allows it to be digitized and saved in a larger computer network. This is regulated by DICOM, which stands for Digital Imaging and Computers in Medicine.